It's like having Mr. Murray on FaceTime.
Right? Okay. So today we are going to, let's bring your attention up to the board here. Thursday, daily agenda force and motion study guide is what we're going to be introducing today. What I will tell you is that here's the timeline for the remainder of October, if you can believe it. We're almost halfway through October. So today and tomorrow, you'll be working on your study guide as well as missing work. I will tell you that your priority is activity number 15, which we completed yesterday. I did get a chance to look at and grade all of the ones that were turned in. And for the most part, everyone did very well. There were only a few little things here and there, but everybody did great. And I think everybody here would agree that was a pretty difficult assignment. So you all did great. So congratulations on that. So again, today, finish up 15 if you haven't. Then work on your missing work, because all of your missing work is due when? Tomorrow. Okay. And then start on your study guide. The study guide is relatively long, but you shouldn't have a problem with it. It's everything that we have covered over the last several weeks since the beginning of school. So go ahead. It is. It's a doc.
Okay. And then what should our score be? Like, what should it be about?
Your score should be about 100.
Okay.
That is my expectation.
A+.
A+ for everybody across the board. That is the expectation. No problem with this class. All right. So just again to give you the heads up what else is going to happen. Monday is assessment prep activity. Then we're going to do a review game. Woo! Oh, wow. I expected a little bit. There we go. Wow. Okay. And then final study guide day for Wednesday. Thursday, CER prep, and then Friday writing, CER. 8th graders?
I don't want to speak up.
Come on, throw it out there, Kendra.
It's just basically like a big like piece we have to do about it.
Can you speak up so everyone can hear you?
Yeah, it's basically just a big writing piece we have to do about like everything we learned and has to be like very in detail.
All right, what does CER stand for? You don't go ahead.
Claim evidence reasoning.
Claim evidence reasoning. It's very fun. Get excited. Okay. Then Monday will be a model assessment, and Tuesday will be a multiple choice assessment. So you've got some time to study for your test, work on your study guide, okay? So again, study guide will be last after you finish activity 15, after all your missing work is turned in, then study guide. Any questions on that? Ram?
This study guide also after you know, like, if you have any assignments at number 1, you have to then after that, right?
That would be a good idea, yes. Go ahead.
About how long is this study guide?
I don't think it's very long.
Yes, it should be 8 hours at least. There's like 40
Go ahead, Carl.
When you mean for, for the thing for 15, like if you got a 1 on it, change it, and then if you have any outstanding work for science,
Correct.
work on it, and
then study guide. Correct. Correct.
I just wanted to make sure that we didn't have those surprise assignments that went on when I
Correct. So if we talk a little bit about studying, what are some ways that you have found effective for studying for a test such as this? Go ahead.
First, you can start by studying the vocabulary and other past assignments that you have.
Excellent. Go ahead.
study, but not too hard, and then go to bed the night before, have a good breakfast, come to school thinking that you're gonna do it, even if you are gonna fail. Just have the good mindset.
But you're not going to fail. Those are all good things to do. Definitely get a good night's sleep and eat a good breakfast. That's really important. What else, Mauricio?
Usually during the test, you should never like panic over some hard equation. Just keep calm and solve it because usually tests cause anxiety, which leads into you not getting the problems that you're supposed to.
Absolutely. Don't panic. Just stay calm. It'll come to you. And if you need to move on to the next one and then come back, that's okay too. Okay. What else? Kendra?
So for the past like 2 years, I've been doing this. So me and my friends, it's like one of us would say the definition, and we would have to guess the vocabulary word or term. So then it's like you learn stuff and like you get to remember it, but it's not like boring and it's kind of like a game.
Yeah. Okay. Good. What else? Ran.
This probably won't work. But I might ask my parents to do this. If they quiz me, every time I get it right, I get $1.
Ooh, that's a lot of incentive. I'm not sure which friend is going to agree to that though. Don't ask me. I'm not going to do it. All right. What else? What are some ways that we can retain information better?
Have a cheat sheet and it's allowed.
Okay, not allowed. I'll tell you that much right now. What else? What else?
Do before you go to bed, because when you say that's all you think about before you go to bed.
That's actually, there is some science to that your brain does sort of like a computer. It stores files while you're sleeping. So if you have something fresh in your brain before you go to bed, it can get into your memory a little bit better. So that's actually a good point. Go ahead.
For me, when I can't really remember words or just how it's spelled, I usually like break it apart and make it into like little bits and parts that I can remember individually and then put them together. It really works.
Good. That's a great suggestion. Break it down.
Definition, you break up the definition and into individual memories and then you put them together.
Excellent point, because a lot of words have a root meaning in it too, that if once you learn the root, you can apply that to different situations. Go ahead.
You can also study a bit earlier and go to bed early, and then wake up just a little bit early, like 10 minutes before you actually wake up, and give like yourself a little review.
Great idea too. Nice refresher in the morning. Let me just show you one thing on the board here. So we use, do we need this, Mr. Osmond?
Not anymore.
Okay. So we have multiple senses. How many senses do we have? 5. There we go. So the more senses you use while you are studying, the better the retention will be. Okay, the more you will remember. So if you just simply hear something, how much do you think you retain?
Maybe like 1/5 of it, because you're only using one of your senses.
You're right. It's somewhere about 17-18%, okay? If you say it, now these are individual. What is it if you say it out loud?
2 in 5 chance that you're gonna remember it more.
2 in 5 chance. What's that percentage?
I just did this one. 34%.
40.
40.
2 out of 5. So if you made the 5 a 10 and the 2 a 4, you following that?
No.
We'll talk about it later. It's 40%. So it's not quite that high. It is somewhere around 13. I'll give you percentages here. Now, if you see it, what is it? It's actually a bit higher than that. It's closer to 60.
Oh, jeez.
So now, guess what happens when you use all 3 of these? What do you think it? It's about 87%.
Oh, jeez.
Okay, so what does that tell you? What does that tell you when you're studying? Okay, go ahead, Mauricio.
Maybe maybe while you are reading, you can combine the see and say and remember it more.
Right, exactly. Yes, the more you can combine it. Go ahead, Rayan.
Have a mixture of all three. So yeah, when you read it, you have the word on repeat, and you say it. So then you have like three different. You gain 3 times.
Absolutely. Anybody else have a suggestion? Go ahead.
So you can read it 3 times, and then write it down 4 times, and then say it 3 times.
Absolutely. And repetition is the key. But again, remember, use it all. Use all of your senses. Have somebody quiz you. Use flashcards, but try to use as many senses as you can. The more you use, the more retention you'll have. Go ahead.
How would you use taste
You couldn't. Not for this.
and smell and taste it?
You could smell victory by studying.
You can smell color too if you get 100%. Then you're
That's right. Smell the eyes. Go ahead, Quinn.
I'm pretty sure.
Okay, well, let's throw it out when we get a break. Thank you. Okay, so let's do a little review. So first of all, this is what your study guide looks like. There are multiple definitions on there, and they already give you the answer, which is nice because there's a little more work after the definitions, right? Okay, so let's do a little review before I set you loose to finish your activity 15. Then what comes after 15? Missing work. Then? Okay, very good. So let's review. First of all, here's the thing. A lot of times we work in partners, in groups, right? So what do we think about when say for instance, you're working in a group of 2. What do we think about if we're working in a group of 2 and one person does all the work and then the other person just copies?
No learning potential.
No learning potential. Is there a little bit of a feeling of, hey, you know what, I'm pretty smart, somebody wants to copy from me? There's a little bit of that. So sometimes we have the tendency to want to just help people and give them the answer. It makes us feel good, like we're helping someone else. We know the answers. But are you really helping someone else? You're not helping anybody, because in the end, you all have to take your own test. So if anybody just does the work and then lets somebody else copy, it's really not helping anybody. I mean, yeah, you can get your assignment turned in, right? And you might get your 2, but that doesn't really serve you very well when it comes to test time. So just a heads up, I've seen a little bit here and there. So just be aware of that and be cognizant whether you're on one side or the other, or sometimes you take each side a little bit. Just make sure, do your own work. You're gonna have your own benefits from it. Let's see. Activity 15. Question 2. I will give you a hint on this. This is your freebie for the day. That on analysis question 2, it talks about listing a scientific concept. Most people gave an opinion. So if we look, Mr. Osmond, do we have that assignment? I didn't ask ahead of time to have that. Yes, 15. Analysis question 2. So everyone did very well on 15. There was just one question that some folks didn't quite answer. So the question, and this goes into what we talked about yesterday, which is really slowing down to read, what is the question asking you? So it's asking you, what is the most important scientific idea or concept that influenced your thinking about the design problem when creating your safety design? Scientific concept. That doesn't mean I think automatic brakes are a great idea. That's not a scientific concept. So what would be a great answer for this analysis question? A lot of you had a great scientific answer or scientific idea. Go ahead.
Anti-lock brakes can help the car not skid, I think, from what we learned back in September.
Okay, that is a true statement.
Mm-hmm.
How can we make that more scientific? How can you relate it to what you're learning?
During a lab that we did, during lab 8, I observed that when you add less mass or whatever about like something, so like use your background knowledge from the labs, because our science teachers don't send out the lab just to force us to do work. They put a meaning behind it.
That is an excellent answer. What is the scientific concept? Go ahead.
More friction with wheels. Back to the time where we built the mousetrap car design. Ms. Rosman said that we should add like little tires on our wheels so that it would give more friction.
Okay, good. Friction. That's excellent. That's a scientific concept. What else? Mass. What about mass?
Like the mass, there's true cars, longer stopping distances.
Excellent. What else? You guys are right on it now.
Speed.
Speed. What about speed?
So for speed, the faster you go, the longer the stopping distance you're gonna have, most likely.
Excellent. Okay, what else do we have? What other scientific concepts have we learned? We've learned a lot. Think about Newton's 3 laws of motion. Oh, go ahead.
So an object in motion stays in motion unless it is acted upon by a force equal to or greater than. So when we were doing the blocks and the cars, the more mass that we would put on there, the farther the block would go, because there's more mass on the cart transferring the potential energy from when the cart was at notch A to the kinetic energy when it was going down the ramp, and it transferred the kinetic energy to the block moving the block.
Wow, you're talking like a scientist. I like it. Go ahead.
Going back to Newton's first law and second law, this is what Carl said, when there's an object will not move unless it is being pushed or held against another object.
Exactly. So when you're answering a scientific idea or concept, think about Newton's laws and how do those laws apply to the exercise. One of the questions also said something about what else can you think of basically in a scientific format to help you design a car? It just comes down to the 3 Newton's laws, right? 3 laws of motion. So if you think about all the questions that you get and you relate it back to Newton's laws, the 3 laws of motion, you will get a better idea. Force equals mass times acceleration. Okay, so if you can remember that, when a car is accelerating, mass and force are impacted. When a mass is changed, force and acceleration are impacted. Okay, so that's your freebie. So if you need to update that, go ahead and update that. Any questions? You guys are, oh, go ahead.
Do we have a lesson for today, or is it just to work on this alone?
Right, so we're going to finish activity 15. Then we're going to clean up any missing work. Then we're going to work on the study guide. Okay? All right, so, sorry. Let's see. What are Newton's 3 laws of motion? Go ahead.
You want to say all 3 of them, or just like?
Yeah, you don't need to do it in order, but.
When is an object will stay in motion until acted upon by an unbalanced force, was it? Or the same force? But no.
Okay.
And I forgot that I do.
You're feeling pressure. Go ahead.
F equals MA, and there is for every action, there is an equal and opposite reaction.
Correct. Excellent. Excellent. Go ahead.
And then my favorite one. An object in motion stays in motion unless it is acted upon by a force that is equal to or greater than.
External force. Correct. Yes. Excellent. Anybody have anything else to add? You guys did a great job. You learned the 3 laws. Did you think you'd come this far in 6 weeks? That's outstanding. You guys did great. Okay, so we're going to look at we talked about this. What is the mathematical equation for the second law? Somebody already said it. Okay, how can we change this formula to solve for mass? Go ahead.
Force divided by
Divided by what?
acceleration.
There we go. And if we are solving for acceleration, what's our formula? Go ahead. There we go. I hope you guys are taking some notes here because I'm giving you some freebies. Okay. Of course, you don't really need these freebies because it seems like you already know all the answers. So that's outstanding. What about graphing? If I showed you a graph, okay, we've got, how do we solve for speed?
Speed equals mass. No,
Go ahead. Excellent. Excellent. Okay. So if we've got our distance and we've got time, right? If we've got a graph like this, what does that mean? What is this? Go ahead.
Well, when it goes up, they're accelerating, and so they're going to their destination. That makes sense. They're not going anywhere, but like time keeps ticking, and then when they're going down, they're technically still accelerating, but they're going like, let's say they sit at their house and they're going to school and they're driving homework.
Excellent. High five. That is excellent. Remember that just because you're going slower doesn't mean you're not accelerating. Accelerating is the change in motion over time, right? Okay, very good. Now, if you have 2 graphs like this, again, distance, time, you've got someone that's doing this, and then they go like this, somebody that goes like this. Who is going faster first?
The one on the left.
Excellent. Excellent. This is showing a steeper incline, so that's faster speed. Very good. You guys are good. You're going to have no problem with this study guide. Let's see. Balanced forces, balanced and unbalanced forces. What is the unit of measure for forces? Newtons. A big N. So if you see N, you know that you're solving for force, a Newton. Okay, so what is an unbalanced and a balanced force?
A balanced force would be if an object, so let's say this pencil case, if it's not moving, then balanced forces are acting upon it. If it is moving, like it just was, then that would be unbalanced forces.
Okay, somebody give me an example from your activity doing this.
From the train thing, the part.
Right.
When you have 2 weights on one side, and if they're both of the same mass, then stay the same.
Which is what kind of force? Balanced or unbalanced?
Balance.
Correct.
But if they have different masses, then the one with the greater mass is going to go down to the gravity. That's how gravity works. And
Right, and that's what kind of force? Unbalanced. Right, there you go. Excellent, excellent. You guys are going to have no problem with this. So that's our review. Those are your freebies for the day. Go ahead, finish up 15 for those that haven't, then missing, then study guide. Any questions? If you have returned assignments and you have questions on them, now is the time to ask me about them, okay? All right, get to work.
I have a question on 14.
Okay, I'm ready.
Try AQ4 again and use the data chart or graph for more specific information. And look on it. Wrong app. That one. And I'm confused when I need to fix.
Okay, so let me look. Okay, so we're not really looking at reaction time. We're looking. You're thinking too hard. Look at the graph, and it says use the analysis item 3, so the question above, and then apply it to something was distracting you. So then you'd use the distracted driver, right?
Distracted.
Right, and you would look on the graph to see where that lines up.
Oh, so I just say crash because that's what the graph says.
If that's what the graph says, but make sure it's the right answer. Okay, so look at.
I know it's the right answer. I just thought too hard. Okay.
You thought you were. Yes, you may.
I had that problem that you were talking about in class.
You had what?
I had the problem that you were talking about in class.
Mm-hmm.
How do I fix that?
So how can you apply any of Newton's laws to, so you're talking about the scientific idea could be attaching a GPS that tells you what street you're entering. How does that apply to force, mass, acceleration, balanced forces, objects in motion?
Well, I guess we would talk about the objects in motion because the car's moving, but other than that, it doesn't really science.
Oops. Okay, so I guess what you need to just answer is the why. So if the speed limit, you want the speed limit on the GPS, why? What part of science is that important?
They won't go over the speed limit and get in trouble.
But what's the importance of speed when you're thinking about the safety of a car? Well, you don't, but what also happens when a car is going faster than a car that's going slower? What happens to the safety aspects?
They would probably collide.
No. If one car is going slow, one car is going fast, what is the difference in,
There's unbalanced forces.
well, what about how long does it take to stop?
It would take them longer to stop.
That's what you need to draw in there when you're talking about this. When you're talking about speed, bring in the concept of the more speed, the longer it is to stop, then there's more likelihood of an accident if you're speeding. That's why GPS would be good. That's how you draw it back to a scientific concept. Does that make sense? Okay. Your what? Your iPad for your charger? You brought your charger, not your iPad?
No, can I grab my iPad from the charger and station at the library?
Yes, you may.
So I think Evan misexplained that just a little bit, because you remember the acceleration only occurs when the change in speed happens, not just because it's moving away.
This is it, and that's that.
Yeah, like so.
But right here, it's not.
Well, no, when it's going like this, it's not accelerating in the middle. It only accelerates at the very beginning when it starts.
Okay, we had this right when it's the very beginning.
Yeah.
Right, not the whole time.
And I
Exactly.
talked-
Yeah. Oh,
Hello.
hello.
So,
Okay. You're shaking too much. I can't read it. Okay. Use your data from part A to answer question 2 again. Where is your...
so this is what I did. We don't look at this.
Oh, maybe I didn't see that. Did you resubmit just that?
Yes.
Oh, I didn't see
And
that.
I added this. But this has been on here. I just did this.
Good. Send it back. I didn't see the other attachment. Sorry. Thank you. I know. I'm like, we didn't change anything. Sorry.
Have a strategy.
Oh, I'm ready. What's your strategy?
Take a post-it and I'm gonna put the definition on it and I'm gonna put the word underneath it.
There you go.
I'm doing it. Sure. I'll write all the definitions and then in the past, the ones I
Tie your shoes. Well, what does it say? Did you read the directions? Are you sure? Hold on 1 second, Evan. This is what you have to show. Complete some method for showing how you studied these terms. Put your proof of studying in the box.
I need help with 12. I don't know which one it was I needed to fix.
Wait, sorry, what's the question?
I need help with 12. I don't know which question it was.
That I sent back?
You didn't send it back when you talked about it, and I don't know which one I did, if I did anything wrong.
Okay. No, those look good. That looks good.
Now, what's your plan?
Excellent.